Guys, my name is Femi Ayeshoro. Today, our focus is going to be on functions, and we are going to talk about functions. We are going to look at functions, how to write functions, various ways, and all of that. So, everything about functions, that is what is going to be our focus in this video. And one thing about functions are the basic building block. So it's important to really understand functions. There is no way you are not going to write functions. So it is important that we understand functions and understand various ways, the various types of functions, how we use it, and everything that has to do with functions. So there's a document that I've prepared. We are going to go through it, and then also I'll also be writing code to show us this is how it is and all of that. So by the time we are done with functions, we'll take a look at arrays. We talk about arrays, we talk about slices, we talk about map, and then we end it there today. All right, now without wasting time, let's get right into the code. But before that, I want you to consider subscribing. I want you to like, I want you to drop comment for me. That I really appreciate if you do that. Thank you. So what are functions? Functions are the building block, are the basic building block of the Go code, right? So that is what functions are. So functions are there for us to keep our code simple, right? And then keep it clean, keep it dry. We are not repeating ourselves, all right? So that is what functions are. And okay, so I'm going to be showing us examples. We are going to be writing a lot of code. All right, so I'll just take these points. I'm just going to take this point now, and then we move over to writing code. So functions are the basic building block of the Go code. Functions are kind of a data because they themselves are values and have types. So we are going to be seeing this, right? Every program consists of several functions. So if I show you an application that I've worked on before, all you see is you are just going to be seeing loads of functions there in that application. It is a basic code block. The order in which the functions are written does not matter, right? So if you write a functions, let's say you have series of functions that you have written, it doesn't matter, the order in which you write. It doesn't matter which one comes before which. Okay, so what matters is going to be how you are calling the functions. Okay, so however, for readability, it is better to start with the main. So we have seen that the main is the entry point to our application, right? So when you write a good code, you have to you start from the main. Everything starts executing from the main function. All right, so and write the function in a logical order. For example, the calling order. So it doesn't matter how you have defined your functions, right? What matters when you want the function to execute is the arrangement. All right, so which I'm going to give us an example very shortly. So the main purpose of function is to break large problems, which requires breaking many code lines into into a number of smaller tasks. So you have a large problem. So what we can do is we can package them in functions, right? Functions are like boxes to take care of something specific, take care of specific things, take care of specific things, and that makes our code readable, right? That makes it easy to understand. That's what function does. So instead of writing everything together, we can break things into small code in blocks of functions. So that is one usefulness of functions that we are going to be seeing in this code. All right, also the same task can be evoked several times, and that is one unique thing about function, right? So that means that I can write a function that adds two numbers. Okay, so give me any two numbers and the function will automatically give me a result when you call that function. Right, so it doesn't matter the number. So it could be 10 and 5, it could be 100 and 2, it could be 1100. So it does not matter. Okay, so it will just give me, so I can keep evoking the function. So these are terms, these are things that we are going to be learning in this course. So a function promotes code reuse. All right, so we don't have to be repeating ourselves, right? I can just write functions that add two numbers together. I can write a function that sums two numbers together. I can just do stuffs, right? I can write a function that divides numbers. So I don't have to be writing them repeatedly. I just have to write it once, and then all I have to do is to keep calling the function. In fact, a good program honors don't repeat yourself. Don't repeat yourself. As a developer, we try as much as possible to abstract things, put things in functions so that we don't repeat ourselves. principle, meaning that the code which performs a certain task may only appear once in the program, so we don't have to repeat ourselves everywhere. So let's say I need sum of two numbers in 3 places or 5 places in my program. I can just write it once in a particular file and then import it into several areas that I need it. So you don't have to repeat yourself when you write functions, right? And then we have 3 types of functions. So before we move to the 3 types of functions, I want us to write some code. I want to write some code that clearly explain the things that I've written here. So let's go back to our code. So we started from understanding the fact that in your Go code, we have a main func. Yeah, we have the main func, and it doesn't take any argument, right? So this is very simple, very straightforward. Then whatever functions that we need, right, instead of putting it here, because in between this place, anything you put inside these functions, inside the main func, yeah, inside this main, gets executed, right? So instead of writing a lot of things here, I'd rather call the function inside here, and this is what I'm saying. So I'm just going to let me just so let's take this out. Okay, let's take this out. All right, so I'll just write it outside here, and then I'll call it inside this place, because once we run the program only executes this function, right? So that is that. So I'm going to start with functions as the building block of any Go code. All right, so let's write a function. Let's do function. I'm going to write something like func. So don't forget that in Go, we don't write functions, we write func like this. We don't complete the function words, we just write func, right? Not like JavaScript that you have to write function. So comes after the function is the identifier. I mentioned the identifier is the name of your function. So the name of this function is greet, and then we have parentheses, and then we open the braces. That is it. So that is function for you, right? So very soon later we are going to see how we can pass in arguments to the function, right? So arguments are more like variables, things that are needed in the execution of that function. So we are going to be seeing that soon. But this is a basic structure of a function, right? Start with the func word, identify which is the name of your function, then we have our parentheses, and then we have braces. So I'm just going to do fmt. I want this function to just print something for me. Let's see, hello, welcome to understanding functions in Go, and that is it, right? So this is a basic function, right? So very simple function. I've written a function like so. One thing to take note here is that I am not returning the function, rather I am printing to the console. Okay, so I'm using the print, the fmt, to print to the console. So I want to see hello, welcome to understanding function in Go. All right, so what we can do is to come inside our main. I've told us that the main is where our code gets executed, right? The execution starts only in the main. So we are going to come here and call the name of the function, right? So the name of the function is what? Greet. So whenever we write a function, right, we also have to invoke the function, right? So we use the word call, invoke, right, the function. So if I don't do this, let me just take this out. For instance, let's try and execute this code, right? So let's see what we are going to have. Go run main. What do we see? There's nothing in our console. Nothing gets executed. Why? Because we have not executed the function. So when you write a function, you also have to call the function. So you write a function, you invoke the function. So we are going to call the function now. So let's call the function now. So we are just, since we are printing to the console, then we can just call the function. So how do you call a function? How you call a function is the name of the function and then followed by parentheses. That is very important. That is very key. So you invoke a function at the end of the name. Make sure that you have these 2 parentheses there. That is what it means to invoke a function. So We are going to run our code now. Go run main.scope and let's see what we have. What do we see? Hello, welcome to understanding function in Go. I think that is pretty basic and very simple. And one beautiful thing about function is that instead of repeating myself by duplicating this, we can as well call this as many times as possible. So I can come here again and just invoke it several times like this. So I'm going to clear this and then we are going to do go run main. So what do we have? Hello, welcome to functions in Go. We can see the we can see that this is printed 3 times. So we don't have to repeat this 3 times. So that is one beauty thing about functions, right? That you can write a function and call it several times. All right, so that's about function. So I'm going to comment this out, and then I'm going to comment this out. So from this definition, we are seeing that that's the basic building block of code. So the next thing we are looking at is functions are kind of data. So what it means is that we have a variable. I talked about variable in our first video. Variables are containers. Variables are containers that you can store something inside your variable. When you have a variable and you initialize that variable, it means you set a value. So functions can be values, right? So you can have a variable that the value of that variable is a function, and we are going to be seeing that right now. So we are writing a function now. We are going to write a function as values, right? So what we are dealing with is functions as values, function as data. Do you get now? So that is very important. So what we are going to do now is we are going to write a function. We are going to write a function that adds 2 numbers together. Don't forget the identifier. We have a. So now, what's the difference between the first one and the second one? The second one has a parameters. So it means that when we are invoking our functions, we want to be able to pass in values, right? So that is very important. So we have a. So this is like whatever we put inside this parentheses, we call them arguments, right? So that is what we are doing here. So we are passing arguments. And whatever argument we are passing is just more like you are passing a variable. We also have to specify the data type. So it is important that whatever thing you are passing in as argument, you also have to specify the variable. Very important. So we are passing 2 arguments, which is I'm representing it with a. I'm giving it a. You can see that it's a var, right? Can you see it's a var? So whatever we are passing here, they are actually variables. You have to also have to specify what the data type. So we have a. So I'm also going to do b. Can we see now? So this is pretty basic. So since a and b have the same data type, so I can as well write it this way. I can as well write a and b, and then I put int this way. All right. So this also works, right? A and b. So I have a command a, b, and int, because a to just separate the variables. No, this is a separate variable. You can see variable a, right? Variable a, and then this is what? Variable b, and they have the same what is it called now? They have the same data type, which is what? Integer. All right. So and then we are going to follow with our braces. Now what do we want to do? What we want to do now is we don't want to print to the console, right? Because we want to be able to set our values. All right. So it's just like somebody gives you a phone and then you want to call somebody. You don't want the person to dial the number for you. You want the person to give you the phone so that you can dial the number yourself. So that's what we want to do. So we are not printing to the console yet. So all we want to do is we want to return that value. So that's what we want to do. So what we want to do is that, okay, give me a notebook, and then it should be blank, like a blank check. Don't write it. Let me be the one to do that. So we want to be in the control of that. So that's what we want to do. So we are going to use the word return. So return a plus b, right? So that's what we want to do. So since no value has been specified yet, what we want to do is that when we invoke this function, we want to be the one to give it the value. All right. So one quick thing that we are going to notice here is there's a red line here. And why we are having this red line is because in Go, whenever we use the word return, let me just put it here. Whenever we use, let's just write return. When we use return in our functions, we have to state the type of data type that we are returning. We have to state the data type that we are returning. That is very important, right? So in Go, when we, let me just put it down here. So in Go, when we return in our function, when we return the keyword return, we have to state the type, we have to state the data type that we are returning. So, and where do we state it? We have to state it here, just before the braces. So what are we returning? We are returning integer, right? So we have to state it here, integer, like this. And what do we see? We see that red line has gone. So in Go, whenever you are using the return word, you have to state what you are returning. If it's a string that you are returning, you have to state that is a string. If it's an array you are returning, you have to state that it's an array. If it's a struct that you are returning, you have to state that you are returning a struct. If you are returning a pointer, you have to state that you are returning a pointer. That is very important when we are working with Go, right? So that's what makes the function that you write in Go different from every other programming language, like maybe Java or Python or JavaScript. You don't necessarily have to state your return type. But when it comes to Go, we have to state what we are returning, the data types that we are returning. So this function is only expecting integer as arguments, right? So the functions we are writing here is only expecting an integer. So you can't come and pass string, it will give you an error. So what we are going to do right now is we are going to invoke the function, right? So maybe the expectation will just be for me to call hard, right? So if you do this, yes, it's not going to work because we need to print to our console, right? We are not printing to our console. So what we are going to do now is to do it properly. So I'm going to set a variable. So I'm going to call it results. I'm going to define a variable. So I've just defined a variable results, and then I'm setting it into what? This is a variable results, right? So a short way of declaring a variable, and then this is giving us line because it's expecting us to pass in two numbers. So what are the numbers we are going to pass? So let's pass 7 and 8. So we can see that the red line has gone. So we only have its result. So we can now print to the console. So we can do fmt.printint like this, or I can use printf. Okay, so let's do this. Our function is, so if it's integer, we have to use d. So what we're going to do is we're going to have results like this. Can we see now? So this is just to format it well. So the result of addition is, so the result should be here when we run this code. So what we are going to do now is clear this, and then we are going to do go run main.go. What do we see now? We are seeing the result of addition is what? 15. Okay, so that is what we have. The result is what? 15. So the question is, why are we using print? Is because if I don't use print, you are not going to see anything. So what helps us to see it is because I have to use print, right? Because we are only returning. So returning gives us that leverage, that leverage to set it into whatever we want, right? So we can as well write another, let me just say p. So I'm defining another variable and then invoking the function again. So let's write 10 and 89, right? So we can come here and just do fmt print like this. So let's print results, and then let's print p. So you can see that the same function I'm invoking twice. First time I'm adding 7 and 8. Second time I'm using 10 and 80. Okay, so and I'm invoking it here like this. So when we come here, what do we see? Let's check what we have. What do we see? We are seeing, what do we see? We see 15. So that means 7 plus 8 is 15. Then the second one is what? 99. So this is the result. So what we are seeing here is that we are seeing that you write a function that adds two numbers, and then you can keep evoking it severally, right? I can write a equals to something like this, add again, and then just do, maybe I do 20 and then do 10,000, right? So instead I can still write it and put a, right? So by the time I invoke again, you expect to see, what do you see now? You see 10,020. So just one function, right? And you can begin to add as many numbers as you want. Any numbers that you want, you can write. So this is the power of function, right? And there's something I want us to take note here, that functions are kind of data because they themselves are values. So you can see that the value of the variables that we've declared here, they are functions, right? So it's a function that is a value of the variables here, right? And it can also be a var keyword. So I can write it as this, var keyword. So this can also be a var, right? So all I just have to do is to do here. It can also be a var keyword. So you can see that there's nothing, right? So that is that. So that is that about functions. So they themselves are values because you can set them as values inside variables. All right. So that is that about function. So I also mentioned that the order of the function. So let's quickly. So before I leave this list, let's say what we have here is a string. So let me just do string 30, and then let's just do string 10. So we can even see that I'm even getting error already. There's a red line already saying that cannot use 30 because on type string. So we cannot use string because what is expecting is what? What is expecting is expecting integer, not a string. So I'm going to just comment this out, and then let's write, I want to write series of functions. So let's say func say by like this, fmt print hello goodbye. So I'm going to just repeat this function and say hi, there. All right, so these are two functions that I've written. So we can see that from what I've written, right? So let me just take these guys out. So you can see that from what I've written, this comes first, right? So I'm going to call this one first. So what I'm going to do is to say hi, invoke at that, and then followed by what? Say bye. So that's it. So even though in the order here, say bye comes first, but when I'm calling it, say hi comes first, and let's see what we have. What do you have? Hi there. This comes first, and then hello bye. So it doesn't matter how you define your function. It doesn't matter the order. What matters is how you are calling your functions, right? That is what matters. Which one comes before which? Like I would like to show us something really quick. So let's come to the main, like this example code now. So the observation is that for me, I want to do something. So here, right, I have to call the database here, right? So this is coming from database.new. So database.new is where I'm setting the database for this particular application. So you can see that in this place, where is data.new? So data.new is here. So you can see that here is where I'm doing all the configuration for the database. I'm using SQLite 3 and all of that. So this is where I'm doing the configuration for the database. I'm creating a table here. So this is a table that I'm also creating here just to give us an example, right? So this handles the database connection or connectivity setup and pinging and all of that. So if you come back to my main, right, so I just want to show that I had to call it here first, right? So these are just structs. When we get there, we understand. So I had to call it first because the result of that function, right? So the result of the function. So what this is like, this is just giving us that the function I've done has two results. The same way that we have a function here, the one we did before, that's like for this add now, is going to return just one. Okay, so you can see that the result is results. So what we had before was we have results in our main, a function that now says add something like this, maybe 30 and 5, right? So the result is giving us what is returning. So your function is just returning integer. So that is why we have these results, and then we are printing in the results. So I believe that we understand that. So that is so in this particular case, if I go back to my new, you will see that we are returning two things. So it's possible for us to return two things, and I'm going to show us that. So we are returning this sql.db and error, because error in Go is a value. Error is treated as a value. So if you come to our return, what do you see? You are seeing that I'm returning two things. In our case here, I'm only returning one thing. So I'm only returning A plus B. So it's possible to return two things in Go, which I'm going to show us shortly. So what I'm just trying to say is that the setup is done here. Then in my main, let's go back to main. I have to call it here. Why? Because the result of the DB, the result of the function is needed, number one, to close the database. We are going to see the use of this defer keyword here, like this. Okay, so, and then it's also needed in this place. You can see the DB. I need the DB. So the order of the function is extremely, you can see I'm using so the order is very, very, very important. The order just gives you like, okay, what do you want to be executed first? What do you want people to see? So you have to take note of the order of execution of functions. All right, so the next thing we are going to look at is, we talked about, the main purpose of function is to break large problems, which requires, instead of you have a large problem, so you break it down into smaller tasks, and we are going to be doing that right now. So what we are going to do is to break these problems down. So I'm going to write a function now and take this. So let's write a function. We are going to write a function func calculate area. Func calculate area. So in the area we are going to have a length, use comma, width, then it's going to be float 64. It's going to be float 64. So in the float 64, we're also returning that float 64. Then braces. So we are going to return length times width. Right? So we understand what I've done here now. So like almost the same thing like when you're adding two numbers. The only thing is we are returning floats. Okay, so what we are going to now do here in the main is to do length. You can see that the length we are saying, the length is 10.0, right, as a variable. The width is this, is going to be 5.0, right? So we are saying area, declaring a variable called area equals to what? Calculate area. All right, so we are calculating area, right? So we can now do L and W, right? So we are going to do fmt print like this. Is going to be area. So I want to believe this is very straightforward, right? So we have calculate area, we are passing in, these are the arguments that we are passing, right? So functions can take arguments, right? So that is the argument, which is length and width in this case. So those are the arguments that we are passing. So you discover that the argument we are passing to, they are variables here. So you are just we are seeing that we are passing in what? The variables, which is L and W. very straightforward. So let's clear our console and let's see the results. Code.run. What do we see? We can see that the area is what? Is 50. Right, so you can see, so this is also pretty straightforward, right? That whatever variables that you have defined, you can just pass it inside like this. So we're breaking everything down. Of course, you can also directly pass it in. So maybe I can do another, let's say, value and do something like this. Let's say calculate area, right? So instead of having to define it as variable, I can as well just specify, let's say, 8.4, and then 8.1, right? So I can just make this one here. It still should be area. Then this is going to put value here as well. So you can see value. So we're going to clear this. What do we have now? You can see that we have 8.4, 8.1. Added it to multiply. Then this is the result. So very straightforward. We are understanding functions and all of that. So you can see that we don't have to repeat ourselves. Just call the functions. And if you have a variable that you've already declared, in this case, the variables I'm passing in inside the functions, they are already declared. In this other example of value, the variables are not declared. So I'm just passing them directly inside the function, and that works as well. All right, so let's take note of that. So code reuse. I've showed us code reuse, but I'm going to give us another great example shortly now. So I want us to see this example, code reuse. So we can write func print message. Func print message is going to take string. So what we have been doing is number, and then we are not returning anything. I'm going to just do fmt print int like this. So I'm going to do hello, then name. So that's just all we are going to do. So we are going to call the function print message. So since we are passing in a string, right, so it can just be Steven, right? So when we come here, what do we see? We see hello Steven. So I can as well come here again and just do something like this. Let's say stone, then print again. Let's say this one is Trump. Let's say Femi. Let's say Lagos. I mean, Lagos is not a name. Let's say Nigeria. All right. So you can see that I'm not repeating myself. Like, I don't have to write this function many times. All I just have to do, what I'm doing is to invoke the function. You're just calling the function, because in our definition here, we are saying that the same task can be invoked several times. So a function promotes code reuse. So we are reusing the code. We are invoking it. We are not writing the code all over again, right? Like, if you have to do this in variable, that means we have to declare a variable and you have to set it as. I'm going to do that shortly. So let's see what we have. So what do we have here? Can you see hello Steven, hello Stone, hello Trump, hello Femi, hello Nigeria? So printing it. So if I want to do this in variable, what it means is I can just say, let me, for instance, let's say A equals to, kind of Steven, like this, right? And let me just use B equals to Femi. And let's say D equals to Trump. You understand? So if I'm printing it out, so I have to do fmt. I have to print it. Let's say A, C, D, right? Which is not, even this is not. So you get now. So in fact, let me just print it single line. It's going to be C. So I'm going to clear this, and then let's run main. So what can you see? You're seeing Femi, Stephen, and Tom. So I have to be declaring variable one after the other. So you can see what function does. Imagine if I have other functionalities that I have to do. Let's say, so I have to now be doing hello. Let's say I want to do hello here. So I have to do hello like this, right? I have to be writing it like this because I want us to see what function does or what problem does it solve for us. Hello like this, right? So you can see the stress hello like this. So you have to write it one after the other like this. Whereas function just helps you to write it once and then you can call the code. You can invoke several times. So if you come back here now and then you do something like this, what do you see? You see hello fem, hello steam. So functions helps to make sure that we don't repeat ourselves. So the next focus is we are going to be talking about the types of functions that we have, right? So you are going to be seeing functions everywhere in Go. Functions are going to be everywhere in Go, but what are the different types of functions that we have? So there are 3 types of functions in Go. We have the normal functions with an identifier, we have the anonymous function, we have the lambda or anonymous or lambda, we have methods. So I'm going to be giving us difference between a function and methods. So this is extremely crucial, right? So any of these types can have parameters and return values, so that is also very important. So the definition of all the function parameters and return values together with their type is called function signature. So what is function signature? So function signature is saying that when you have all the functions together and their return parameters with their type is called function signature. I want to show us how a function signature looks. This is a function signature. I want to show us a function signature. Where's a function signature? I hope I'll be able to see it. Okay, so this is a function signature. Okay, so a function signature is that the function with the return type. So we hear the word function signature. So if a function is where is it here? So, okay, so I saw the function signature here. All right, so let me just go through. So the definition of all the function parameters, you can see the function parameters. These are the function parameters and the return type together with their return is called, so the whole function is a function signature, right? So I believe that is clear. All right, so we have that, and then function is so we can also have functions in another package, and I'm going to show us because we see from the FMT package that this FMT, this printing that we are calling, is a function in the FMT. So we talked about packages. So a function can be written in another package and is needed in another package, and you can import it. So this is from the standard library. So if I click here, this is a function. So that means I'm using the printing function from the FMT package. So if you come to the top, what do you see? Package FMT. So what I'm going to do now is I just want to show us something really quick. I'm going to take this out. Let's take this out. And then I'm going to okay. I'm going to come here. So let's come to our repo, for instance. So I'm going to write a function here. So let's write a function here. Func greet. So func greet is going to take a name as a string, and then we have this fmt.printint. Alright, so what do we see? I have a function there which is called greet. Don't forget that the rule of visibility is very important. Go is case sensitive. Goal is case sensitive. The rule of visibility is important. So what we are going to do now is I want to call the function inside the app. So you see that this starts with a capital letter, right? So I want to just call the function. So I just want to minimize what I have here. Okay, so let's try and call the function. So how do we call the function? So we have repo, so we can just do so it's going to be repo dot what? Repo dot greet. It's not even going to work, right? So you can see that. Let me just leave this. Let me uncomment it. Greet. So it's not seeing it. So let me change it to a capital letter and let's see if anything changes. So I have repo. You see repo dot greet. Can you see? Automatically brings it out for me. It's expecting what? An argument. So whenever you have to pass in, when you want to invoke it, you call it parameters. So when you're invoking the function, whatever you pass in inside the parentheses is you are passing in parameters. Okay, so we have to pass in a parameter of Steven. Alright, so you can see repo. Why do we say repo? Because it's from the package repo. Do you see from the fmt? So you see fmt print int. This is a method. So you make reference to the package name dot the function. So this is from a standard library. But this is my own package. We created this package ourselves. So if I need to import from this package, then I must make reference to the package. So I have package repo dot greet is the name of the function. So Go is case sensitive. That means any function that will be used outside of the package, we are using it in another package called main, then it must start with what? Capital letter. We can see that fmt print is start with the capital letter. I hope that makes sense. So what do we do now is let's print it out. What do we see? Hello Steven. This is Steven. It's coming from, okay, let me just put Steven Stone. So what do we see? We are seeing hello Steven. Why? This function from this package is being imported here and is being called outside here. I believe that makes sense. So we are going to talk about the different types of functions that we have. Okay, and we've looked at some of them already. So we talked about the normal functions, anonymous functions, and then we talk about method, right? So that is that, and then we are going to look at returning from a function. So returning values, you can see the other time we had to return ints when we added just one number, one thing. So it's done with keyword return. In fact, every function that return at least one value must end with what? A return. Okay, pass by value, that is arguments. So pass by reference. So these are things that we are going to be looking at shortly. So but this is a normal, we've done this, and we can also do something like this. Let's just do something like func multiply as much as possible to have a, right, a b int like this, and then we are returning int like this. All right, so we are going to have return a times b, right? So a times b, so that's what we are going to return. So I'm just going to, let me comment this now, so that since we don't need them anymore. So what we are going to do is we're going to say results r equals to what? Multiply. What are we passing in? We are passing in two numbers. Let's say 10 and what? 76. So what do we do now? fmt.print int like this. We're going to put r. Okay, so let's just do multiply like this. So that's all. We are good now. So we can now do something like this. So what do we see? We are seeing 760. So this works very well. this works very well. So this is a normal function with an identifier. The identifier of this function is multiply. Okay, so this is in response to this. So the other one we want to now do is we're going to talk about anonymous function, right, or a lambda function. So we hear the word lambda function, just a single line function. That is what it means, right? So you see that a lot in other programming, like maybe Java, JavaScript, and then a Python. So but let's do a simple example now. So let me just comment this out and then comment this out now, and let's do a lambda function or anonymous function. So when we say anonymous function is the functions we've written so far. We see that we give them names. There's a name attached to every function that we have created. But in this case, there's no name. That's what we call anonymous function. It doesn't have an identifier. But instead, we are going to store the function directly inside the variable. And this is what we mean. This is what I mean. I mean sum. Sum is a name now. This is a variable. I'm declaring a variable, right? So when you say sum func, so we're going to have a, b, integer like this, and then we are returning. We have something like this. So what are we returning? We are returning a times b. I hope this makes sense, right? So unlike before, this is defined outside here separately with the name of the function, but this function does not have a name, right? So we can just do fmt print int like this, and then we are printing sum. It's going to be sum like this. So we are saying a times b. All right, so why are we having is a print value. Yes, so let's go. All right, so we are going to do, so what are we passing? Yes, sum is a value. Oh, sorry, I'm not done, because this sum now we have to invoke it, right? So I can't just call sum because this function is taking a parameter. All right, so parameter can be 3 and 9. Do you get now? So why? Because the function is an anonymous function. So since we are saving the function inside a variable, so the function is a data here. What we have here is this is a function. This function is a data. So the variable is holding the function. The function is the function is the variable as function as its data. Okay, so what now happens is if you are invoking with what we've been doing before, that we have to print this. So we have to invoke. So this variable name identifier becomes the name, right? Because the function is anonymous function. So we have to now invoke it like this. I hope this is clear. Right, so what we are going to do now is to run it. We are having what 3 times 9 is going to be what 27. So this is an example of a lambda or anonymous function, right? So that it does not, anonymous function does not have a name. The function doesn't have a name. So if you are invoking the function, so most times it's going to be a function expression, right? So in JavaScript we have something that called function expression. We have function declaration, function expression. So this is not JavaScript course, but we can also learn. So we have function declaration and we have function expression, right? So that is, we have these two stuffs in code. So we have function declaration, function expression. So function declaration is you declaring a function like this, right? So this is function declaration. But function expression is you're saving the function inside a variable. So this is refers as function expression. So that means that when you're invoking the function, unlike in function declaration, let's say function declaration, if you're invoking the function, you invoke the function by the name of the function. So in our case here, we have multiply. So when you're invoking the function, it's still going to be like multiply, something like this. Multiply like this. You invoke it like this with the value, let's say 3 and 4. But in the case of function expression, what you do is the name of the variable now is what you are now being invoked like a function, and that is what we have done here, like this. Why? Because the function is anonymous, does not have a name, or is a lambda function. I hope that is clear. So anonymous or lambda function is also exists. And then we are going to talk about method in Go. Right. So when we talk about method in Go, and I'm going to show us a code example here in this past project that we have done. So I'm going to take this out. So we can see that we may not really understand this, but when we get to struct, because I'm taking a session where I'm going to explain structs, I'm also going to explain interface. So I will dive in deep into everything that has to do with methods. So now, what's the difference between function and method? So the difference between a function and method, in a simple term, is that a function is a block of code, right? So that's a major difference between, that's what a function is. Method itself are functions, but methods are functions that are attached to a specific data types. And what does that mean? So I'm just going to show as an example. So we have a struct here. We may not really understand this, but I'll still come back and explain. So we have a struct. Struct is a data type in Golang. So we have different data types, and then struct, int, string, slice, array, function itself, pointers, they are different data types in Golang. Right, so a method, function is basically, you can see this is a function, and we call it factory function. I'll be going into depth when we get to struct. So this is a factory function. What this factory function does is to return the struct. Okay, and it's a pointer. Pointer holds the memory address of the variable, right? So, and we are returning the pointer. So we'll dive deep into this topic. But you can see this is a function. These are functions. These are functions. These are functions. These are functions. But the function we are having here, you see that it has one parenthesis here. It has another parenthesis here. Normally, the way we define function is, after the function, what comes next? The identifier. That is how we define a function. So you have a name of the function, you have the keyword, which is func, followed by what? The identifier. In this case, this is a function. Right? This is a function because you have the func keyword. Going by what I have taught us in this video, we have a function, we have the identifier, and then whatever is going to return will be stated. Because whenever we use the return word, then we also have to specify what is going to be returned. But in this case, after the func word, we have a parenthesis. Inside the parenthesis, we are specifying the data type. We can see that we are saying T represents what? This data type of what? Struct. So the difference between function and method is that a method is a function that is called on a specific data type. So the data type could be anything, but in this case, the data type that we are calling a method on is on the struct that we have defined here. So just when we get to the struct, I'll be breaking it down. And the reason why we are doing that is because when you have a method, right, it's just like if you are coming from OOP language, you are coming from object-oriented programming language, you have a class. So in the class is where you have a blueprint, right? So you have a class, then where you define properties. Then you now have methods, which are also functions, but those methods are defined inside the class. So that those are methods that act, or those are methods that execute the class, the proper. So the essence of it is that these functions can have access to the values, okay, values inside the struct. That is the goal. So how do you now know a method from a function? The way you know is that you're always going to see this parenthesis after the func word, right? And then you now have identifier, and then this function also takes in what? Takes in this following argument as well. So when we get here, we are going to understand it better. So you see, this is a method, right? This is a function, right? So a method will also have access to the variable that is being called upon. So you see that this method is calling this what? This this data type, right? And then it also have access to, so you can see t. This t now is going to, you can see the t.db is useful. So we will understand better, but that's just a simple explanation to give us an introduction to what methods are in Golang, right? So maybe I can, yeah. So when we get to structs, I'll give us a more example. Okay, so let's do an example. Let's do an example to explain this very well, right? So what I'm going to do is, let's come to the top here. We are going to write type, right? We are going to have type of rectangle is going to be a struct. Struct is a data type. Struct. So we are going to have a length t-ish. We are going to have a width. So since they are both floats, they are going to be float 64, right? So that's why we're having it. Or you can also write it this way. So because in struct we have to define, it's like key value, so you have to define the name and the what and the data type. So it's going to be float 64. Then let's do with float 64. So that is that. So this is struct, right? So that struct, we are now going to define a function. So you can just follow, you see, func. What am I doing now? I'm doing har rectangle. So what it means is that har here. So the same way we define parameters. Right? So if you come here, see that I have a name. This one is string, right? This is a string, meaning that I'm expecting a string. So the same thing when you come here, right? In this, I'm having access to the rectangle data type here. So that's just what it means, right? So followed by area. So the area is going to take in nothing. Then it's going to return float 64. Then basics. So we are going to have return. So it's now going to be har dot. It's going to give me har dot length. So can you see how we are having access to this? We are seeing har. Har is rectangle. The struct is rectangle, right? So you are saying har dot. I'm accessing this length. You can see har represents this. It's just like saying har rectangle dot length, rectangle dot width. So but what I'm using to represent rectangle is har. So you are saying har dot length times har dot width. Very simple, very basic. So if you come here, what we now have to do is to instantiate, because this struct is like a blueprint, like a class. You have to instantiate it. So when we get to structs, I'll be explaining very much more deeper. So we have rectangle. We have rectangle. It's going to be like this, rectangle. Then we have to now define our length. So the length is going to be 10. It's expecting a float. So let's say the width is going to be 7.0. So we are done. So let's put a comma there. So we instantiate it. So when we are done with instantiating, if I do fmt now, fmt print int like this, rectangle. So I'm going to be explaining this much deeper. Rect like this. So we should expect to see something. What do we see? We are seeing 10 and 7, right? So we are just seeing the values that is the instance of this. So what I want to do now is I want to call this method. So for me to call the method, I need to first instantiate it with what? With values. So we are going to just come here and do rec.area. Can you see area? That is all I need to do. Okay, rec.area. So to instantiate it, I need to put it in fmt. So let's just do it like this. Let's do fmt print, because we are not going to be seeing it. Area like this. It's going to be what? Rec.area. Okay, so that is because we are returning. We need to print the result. So that's why it's inside here. Instead of printing it here, I can save it in a variable. So you can have like a variable, let's say har equals to rec.area. area like this. So instead of doing it like this, so if I do here, I can as well print it har like this. Okay, so it's the same thing. Alright, so instead of saving it into variable, this is still the same thing. So I'm going to clear this and then let's print out. So what do we see? We are seeing the area is what? 70. That's 10 times 7. That's what? 70. We can see that this is the 2. The 2 is printed out. So that is that. So this is what we are referring to as a method. Right? So you are seeing that this method, this thing that we have here, this is what we call method. This is method, right? So you can see that even though it's a function, but it's acting on the values from this particular struct, and that is what a method is. So we'll still dive into much more deeper understanding of this later. So that is that about method. And then what we are going to do now is to return a value from a function. We've done that. And then what does it mean to return multiple values? Alright, so how do we return multiple values from a function? So I want us to quickly check that out and do that. So how do you return multiple values from a function? So we are going to return, let's say, func divide and the remainder. So we're going to have a, b, they are int. So this function is going to return two things. We are going to get to divide and we are going to get the remainder. So what we are going to do, so initially when we are returning one thing, what do we need to do? We have to put a return words here, right? The data types you can see, we put it here. So here we are returning 2. So and we cannot do something like this. We cannot do. So what we are going to do is to put it in a bracket. Whatever you are returning, once it's more than 1, you put it in a bracket. So this will specify what we are returning and then braces. So we are going to do return a divided by b, right? And then comma a percentage b. Because we are returning, this is one return, integer, this is another one, integer. I hope that makes sense. So where are we calling it? We are calling it here. So let's do har equals to. So since we are returning two things here, so that's the logic. So we are returning two things. So it then means that we cannot just do har equals to like this. This function will not work because we are returning two numbers. We are returning two things. So what we are going to do is going to be, let's do q har. That's the right thing to do. And then what values are we going to put here? Let's put 10 and 3. Okay, so the reason why we are having this is two variables. Okay, so this is just more like saying something like saying var r int, right? Var q int. Do you get now? So that's one of the advantage of this short. So we are defining the two together on the same line. Why? Because the function is returning two things. Alright, so like I showed us, I'm going to go back and show us later. Yeah, so you see that this is returning two things. So when we go back to this place, I remember that when we were in our DB, here what do we see? We are returning two things. We are returning this. So in our return word, what do you see? DB and new. So we are returning error. And so the same thing too. We are returning two things here. This is it. Division and reminder. That is what we are returning. So let's print fmt print like this. So it's going to be the quotient, which is going to be what? Q, the remainder, which is going to be har, and that is all. So let's clear our console. So what do we see? We see that division. So 10 over 3 is going to go 3 times because that is 9. 3 times 3 is 9. So, and there is going to remainder what? 1. So you can see quotient is 3 remainder is 1. I don't know whether we understand. So it's just like, I can define another function here. So that is very straightforward. Like, can have function, let's say add and multiply. So we have a, b int. So since we are returning 2 things, in fact, we can even return 3 things. Int, int, int. So what I'm going to add, multiply, and subtract. Okay, int, int. What am I going to do? So we are going to return a plus b. We are going to have a times b. We are going to have a minus b. Can you see that I'm actually returning 3 things? So the 3 things I'm returning, you have to specify. This one represents the first returns, the values. We are returning 3 things. So if you come here, so we are going to now do, let's say a, b, c equals to what? Add, multiply, and subtract. So let's have 3 and 2 and 3. So we can come here and do fmt printing. So we are going to do addition. So addition is going to be a what we have in red. Okay, see, variable a. So multiplication is going to be, then we are going to have subtraction is going to be what? C. Okay, so very straightforward. What are you seeing? I'm returning 3 things. So whatever, once you are returning more than 1, you see this case, I was returning 1. Here I'm returning 1, so you don't need to put it in brackets. But once you are returning more than 1, you have to put it in a bracket. This one is in a bracket. So what do we do now? Let's clear. So let's do printing. So what do you see? First one is addition is what? 5. You can see 2 plus 3, 5. Multiplication, 2 times is going to give us 6. 2 minus 3 is going to give us minus 1. So you can see this now. I'm able to return 3 things. And that is what makes Go to be unique. Okay, Go is unique in the sense that you can return 3 things at the same time like this. All right, so that is that. So you can change this and do whatever you want to do with this. Okay, so the next thing we want to do now is to, I'm just going to comment this out. So you hear something like pass by value. Okay, so we are going to talk about that. Pass by value, pass by reference. Pass by value, pass by reference. So what is pass by value? So pass by value is you are creating a copy of the value. So I'm going to do something like this. So I'm going to have func change value like this. I'm going to have x int like this. Okay, change value x int. So you're going to have x equals to 100. Okay, so let's call this guy. Okay, change value x. So you are passing in a parameter which is integer x. So we are setting the value here. So what I'm going to do now is to do A. I'm calling a variable and setting it to A. So I'm now saying change value equals to A, right? So let's print it out. fmt print int like this. A is still, so let's check it out. Okay, so what are we returning? This should return int. In fact, here there should be int here, and then we should put a return word here. X. Okay. Alright, so let's clear this console like this. Change value while we're having this line. Alright, so let's do go print. So what do we see? We see A is still 10, not 100. Right? Why is it not 100? Because what are we passing in? We are passing in 10 here. We are passing in 10 here. Right? And we are saying x is equal to 100 here. So we are seeing that is the result of what we are passing here that is being printed out here. So that is what we call pass by value. When you pass any value inside a function like this, you know, if it's in integer, so we have different data types, right? So we have two different data types. Where's my drawing board? Let me get my drawing board. Okay. So we have two data types. We have the value semantics and then the reference semantics. So the value semantics are, so let me just quickly draw something. So let me just draw something. We have value semantics, and then we have the reference semantics or reference type, whatever you want to see. It could be types, it can be, so let me put types in front. It can be types, right? So this is what we have. So the value semantics are, we have ints, we have string, we have bool, we have arrays, we have structs. Do you get? So once any of these data type are passed inside the method, a copy of them will be created. Do we get? So for example, other ones like slice, like map, we have channel, we have other ones. These are reference. So when you are passing a slice, functions, interface, so function interface, right? So whenever you are passing any of these ones inside a pointer, whenever you're passing any of these things inside a function, it's modified the existing data. I'm going to show us very shortly. I'm going to show us something now. So let's do something here. So this is, so we can see that whatever we are passing here is just a copy. So it does not affect the original data. So let's do something different. So instead of passing by value, right? So we are going to do, oh sorry, I wasn't printing here. Okay, so it's still the same example I'm going to use. So the first one is nothing changes because whenever you pass in any of these things, a copy will be created. So, but we want to now use a pointer. Instead of passing in this, we are going to pass in a pointer. So instead, this is going to be a pointer like this, right? So we are passing in a pointer, right? So that is passed by reference, a pointer. So this is a pointer. Then I'm saying that if you remember what a pointer does, right? So what is a pointer? A pointer stores the memory address. Okay, so a pointer is meant to store the memory address of a variable. So when you create a variable, a memory is initialized for that variable. So every variable has a memory address. Let me just do a quick rundown of what pointers are, right? So because what I want to do is say, let's say I created a variable of a, of q, equals to 10. So we know fmt print should give us 10 q. So what do we have? We have 10. So I can have another variable and call it har equals to, making reference to q, right? So if I come here and do fmt.print line and do har, look at what it's going to give me now. Just see. What do you see? So har is storing the memory, is storing what? The memory address of q. So by using this sign in front means that I'm pointing to the memory address of 10. I hope that is clear. So this har is a pointer. Okay, so a pointer holds a memory address of a variable. That's what a pointer is. So one unique thing about pointer is that even though it holds the memory address, it's just like I have your address. It then means that it can access the value because a variable is initialized as a memory address. So in the memory address is the value of that memory, of that variable, sorry. So when we initialize a variable, I mean, if you don't set a value to that variable in Go, what happens is Go automatically set a default value to that variable. So whatever you have inside, you have in that memory address as value of that variable, then a pointer has access to it. So that means that if this variable wants to access this 10, you can see it's printing it out. So I can as well say, okay, accessing the memory address value. So you can see normally it's going to be what? Har, right? So memory address. So the referencing is to access it. And how do we do that? We use another sign like this. We use another sign like a star and har. So you see that I'm going to print the memory address and I'm also going to dereference. So dereference means that I'm going to get 10. Let's see what we've got here. Can you see? So here you can see this 10, this q still remain 10. This q still remain 10, right? So what it means is that accessing, so I can access the memory address, which is this r, then the reference is to access the value. I'm accessing the value of 10, which is this 10 that I have here. But look, what's so funny about this is that since I'm able to access the original data, it then means that I can change the data that is there. And how do we do that? So it means that since I can say, let's say z is equals to z equals the memory address, right? So I'm going to set z to r, right? So what it means is that z is holding what? fmt print. Just want to make this so understandable, guys. I just want to make this so understandable. So you see this is z down here, right? So z is having this. Okay, let me see. Is z. So you can see this is z. So what I'm now going to do is I'm changing the value to be what? 100. So I can't change it like that because it's memory, so I have to dereference it. So I change it to 10. So let's see what z has. So you can, what is z? So I have to dereference it here, not z. So you dereference it. Can. So what do you see? I'm getting 100. So now let me now print this q down here. You see that it is 10 here. So if I come here and print q here, let's see what we have. So funny. I love this explanation. What do you see? It was 10 initially here. You can see that q has become 100 here because by 100 I have changed it here, right? So pointers helps us to modify the existing variable wherever they are. It's just like you have a back door entrance into your room. That is what pointers are. So pointer is just like that back door to enter or to gain access inside your house, right? To do whatever anybody wants. So let's say, let me put something here. Initial value of variable before assigning to a pointer. Okay. Final results of a variable after a has changed the value. So let's check this out. So what do we see? Initial value of a variable before assigning to a pointer is 10. Can you see it's 10? Accessing the memory address, so we can see this one, this, and this, 10. Then final result of a variable after a pointer has changed the value is what? 100. So that is it about pointers, right? So having this understanding of a pointer, we're now going to take this understanding and then apply it to a function. So the same way that we are changing it, we want to be able to do that when it comes to function. So what we are going to now do is, I'm going to comment this out. So what we want to do is come back to our function. So you see this function is taking a pointer. Then inside this function, right, so this is x. So you see that here is just going to give us the memory address, right? But the memory address is not what we need. What we need is the value. So I'm dereferencing here and then now changing it to what? 100. So let's come back to this guy here. Let's come back here. So I have a variable set to what? A. What is A? The value of A is 10. So this cannot work because it is expecting a pointer. Okay? So this is not going to work, but because this guy is expecting a pointer. So a pointer, it has to have this sign. Do you get? Because we are passing a pointer, not ordinary int. Is a pointer that we are passing. So let's now check. So here is now. So if we check what we have now, you see now that it's 100. Why is it 100? Because we are passing a pointer. So a pointer has the ability to modify the existing word data. So going by the definition, so you can see that integer, whenever we pass in integer inside a method or a function, the function creates its own copy of it. So it doesn't affect the same value. It's just like you giving something to somebody, and before you want to give to that person, the person creates a copy of it and give it back to you. So whatever change the person makes to his own is not affecting your own. That's just what it means. It's not affecting your own. But in case of a pointer, it's going to modify the existing data. So so that's different between pass by value, pass by pointer. So we are going to see this a whole lot. In fact, from the code definition here, you will see that we have a pointer. You can see a pointer here. Right, so you are going to see pointers almost everywhere when you are working. You are seeing pointers here. Can you see pointers? So we are returning a pointer. You can see it here. Right, so it's important that we understand that. So as we go along our journey, I'll keep explaining pointers as it relates to the specific data types. But when we have to do with functions, right, it's important that whatever you are passing in as argument to a function, if it's a values, these ones are value type, then you have to use if the value type create a copy, so it is never going to it's never going to change anything you are passing. It's not going to modify the original data. But if you want to modify original data, then you have to pass it as a pointer, right? So that is just the difference. So I did one before that was just pass by value. This one is what? A pointer. Right, so that is that. So the first one is pass by value. This is pass by reference. I think we can stop here, and then so the final thing I'm going to talk about is we have the defer keyword. So this allows the postponement of execution of statements. Okay, so and then the defer allows us to guarantee that certain cleanup tasks are performed before we return from a function. For example, closing a stream, unlocking a locked resource, pointing a footer in a report, closing database connection. You see the defer keyword. Defer keyword is to just help to close an operation. Maybe you are opening a file, you're reading a file, you have to just to close an operation, close the database. So for instance, we see something like this in our DB. What do we see? We see I think I use it somewhere in the main. So you can see it here. So you are seeing defer db.close. So what it means is that after this DB, this DB is what we are returning here. So after this has been executed, first of all, the function has to be executed. It could be in closing a file. So after this function has run, then this function will also run. We understand. So that is how it works. All right. So those are things that we are going to be seeing. So in our next class, we are going to focus on arrays. We're going to talk about arrays, slices, and map. All right. Maybe we now have another video where we talk about struct, method, and then we talk about interfaces as well. So all right, guys. So please, if you have not subscribed, please consider please subscribe, like, and then make comments, and let me see your comments. Thank you. Bye, everyone. Bye.